Hello and welcome to today's webinar, The Future of Farming, Affordable Precision with GEODNET's RTK network, brought to you by GPS World Magazine and our sponsor of the event, GEODNET. I'm Brian, I'm the Senior Marketing Manager here at GPS World Magazine, and I will be your event manager for today's presentation. At this time, I'd like to get you comfortable with our console and the ways you can participate during today's presentation. Please notice the Q&A panel on the right side of your console. If you have a question, please type it in the panel's text box, then click Submit to place your question in the queue. We encourage you to ask and enter any questions you may have for our speaker during the presentation. If time allows, we will address these questions at the end of the presentation during the Q&A portion. Questions submitted during registration have already gone to our speaker and may be covered during the presentation. If you experience any technical difficulties during today's event, you may use the same Q&A panel on your screen to submit your issue, and our technical support specialist, Hallie, or myself will personally assist you. Now I'd like to introduce today's speakers. Today we will be hearing from Mike Horton, who is the CEO of GEODNET. Also, Phillip Owens, he's the research and leader and soil scientist at USDA ARS Dale Bumpers Small Farms Research Center. Third, we'll be hearing from Chris Clifford, founder and managing director at Agri Automation, and Joey Koebelen, founder and CEO of Deep Sand Technology. Now I'd like to turn it over to Mike to get us started. Take it away, Mike.
Thank you, guys. Yeah, so really looking forward to this webinar. We have really three tremendous supporters of GEODNET and partners of GEODNET on the line with the USDA, Deep Sand, and Agri Automation. And these guys have really dedicated their lives and their work to the field of precision agriculture. So it's really with great honor that we've been working with them, and a really excellent opportunity to ask them questions about how precision ag benefits farmers and how it all works. And with that, I was going to do a quick introduction to myself and talk just briefly about GEODNET, and then we'll turn it over to Phillip, who will talk about the work the USDA has done on studying precision agriculture and the proven benefits of precision ag, and then look at a couple of commercial examples here with Deep Sand and their RTK unlocked steering kits, as well as fully autonomous solutions that have been being deployed by Agri Automation in Australia and New Zealand, and then turn to an open discussion on the future of precision ag and any questions that folks may have. Like this to be as interactive as possible, so feel free at any point in time to ask questions, as speakers may answer those questions early or at the end of the presentation. I have a short video here that's playing in the media player to just kind of remind folks what precision is. So in this video, there's a small robot circling in a parking lot, and the purple line is GPS. Again, the purple line is GPS, and the blue line is GEODNET. And really, the fundamental aspect of RTK and what GEODNET does is providing that precision to allow that robot to navigate precisely around in a circle with high accuracy and precision. And you'll see throughout the talk today the real-world need for precision in agriculture and how that precision is utilized in these different solutions that improve farmer productivity. GEODNET now is the world's largest RTK precise positioning network. It consists of high-quality stations that track all four major satellite constellations, GPS, GLONASS, Galileo, and Beidou, with triple frequency support. It's a unique network in that all the stations are uniformed, all using the same antennas. They're all calibrated and monitored 24/7. So it's a quite professional solution, and it is the largest in terms of station count and coverage of any contiguous RTK network in the world. GEODNET is actually fundamentally global infrastructure for precise positioning. And in the industry, you'll hear a lot of different terms used for GNSS corrections. There's RTK, there's PPP RTK, there's PPP, there's satellite delivery, L-band services such as John Deere's Starfire, Trimble's RTX, many different solutions. At the root of all these solutions is GNSS infrastructure, and GEODNET proudly supports all three types of infrastructure, all three types of GNSS augmentation, RTK, PPP, RTK, and PPP. But this talk will really focus on RTK because it's the most accurate, the fastest, and the most usable in all kinds of conditions. The challenge with RTK traditionally has been you need a local base station pretty close to where you're working in order to get the RTK precision and accuracy. And one of the things that GEODNET has been able to do by building such a large network is been able to make RTK more readily available at low cost to all applications. RTK is typically delivered with N-trip, which ensures wide equipment compatibility and makes it very easy to use. Really, the challenge with RTK has again been station availability, which through GEODNET's novel growth mechanisms has been largely solved. All GEODNET stations are monitored 24/7. Their coordinates are set through a PPP process run by software developed by the Natural Resources Canada in RCAN, which is a very famous set of PPP software that determines precise coordinates. What that means is if you're using one station today and another station tomorrow, your position won't shift because all the stations are uniformed and support multiple datums established through the NRCan software. The same software is also used to monitor the stations for movement, and there's online tools that we have, including a quality control database that's really unique in the industry in terms of providing exceptional data on all quality metrics of GNSS stations, including movement, including cycle slips and multipath, including online time and effective satellite coverage. All that data is made available to our business partners who use our network so they can have a full understanding of the station quality of the stations that are on our network at any time, 24/7. In terms of comparing GEODNET with traditional state cores networks as well as other RTK providers in the marketplace, we think that GEODNET offers unique capability with yearly RTK subscriptions that start at retail prices, typically $400 and below, and obviously volume discounts for larger deployments of users. And applications like IoT applications can go way, way, way under that price point on an annual basis. There are over 10,000 stations in our network running, as you saw in the previous slide. There are 14,000 registered stations. There are about 12,000 online stable stations at this moment. Stations are monitored 24/7 with their modern receivers, including support for all signals, including GPS L5, the latest signals from Galileo and Beto, and this is another unique aspect. We support a custom enterprise API for people who want to build businesses on top of GEODNET, whether it's for farming, whether it's for survey, whether it's for robotics or drones. There's a way to use GEODNET for your application. We do also supply data to many of the other industry players in GNSS, including things that would seem to be direct competition to GEODNET, are also using it to provide infrastructure. So it is an open network that really any customer or any application can use for the delivery of precise location services. GEODNET is also unique in that one single sign-in and mount point can be used all over the globe. So if you have a piece of equipment that may be used in the United States, but at the same time might be used in Turkey or might be used in Indonesia, that piece of equipment can use one common configuration for all those applications. It will automatically update to the most prevalent datum in that region without any user configuration. So the flexibility of wide coverage, low cost, high quality, and great availability makes GEODNET a very unique network. This table just shows a quick overview of the type of equipment that it's compatible with. This is not a comprehensive list. Any modern GNSS receiver-based system, whether it's a tractor, whether it's a drone, whether it's a robot that supports the N-trip protocol and RTCM, both of which are international standards, is compatible with GEODNET. Hundreds of different types of pieces of equipment have been used successfully with GEODNET, from drones to farming machines to survey equipment to standalone GPS chips and modules from the folks at Septentrio, uBlocks, Quectel, and many others, all have been successfully integrated with the GEODNET network today. And with that, I really want to invite people who are interested in testing and using our network to sign up for a free trial account, geodnet.com/intrip. It's a 30-day free trial account available to anyone who would like to test and use the network. You can also find our RTK coverage map at rtk.geodnet.com. Again, for a free account, just go to geodnet.com/intrip and you can get a 30-day free trial. Now with that, I wanted to turn it over to our other panelists on the call to really talk about how precise location powers precision agriculture. And I wanted to start off really handing it to Phillip Owens from the USDA. And I wanted to kind of highlight that Phillip has done a tremendous amount of work in this field, and he's published numerous peer-reviewed papers. I just put up a few of them here, 6 papers, all that go into great depth of actual real studies of how precision agriculture is working and is providing improvements for farmers. And it's a really impressive. And so with that, I will turn it over to Phillip to talk about the work at the USDA.
All right, thank you, Mike. And thanks for that introduction. I want to recognize my co-author, Amanda Ashworth. She is a ARS scientist on the University of Arkansas campus. And she's been a partner with me through all of this. And I'm a research leader and a research soil scientist at the Dale Bumper Small Farms Research Center. Prior to that, I was a professor at Purdue University for about 12 years. Got a couple of patents on processes to map soils. Started 2 companies, basically one with Agri to build Advantage Acre to link soil maps to seeding, variable seeding rates. And then the other company is Vincennes to link the maps with predicting soil moisture for high value grapes. So once I left Purdue, I came to the USDA and really focused on technology, because I fundamentally believe that that's the way of the future that will help small farmers and mid-sized farmers, big farmers, to basically maximize their profits. And so this slide shows that, 88% of the farms in the U.S. are categorized as small farms, which means they have less than $350,000 of sales at the gate. The adoption rate for technology is low. I think, one, there's not been a lot of research on it, but also I think not a lot of affordable options. And one thing that we really kind of focused around was this, there's this rule, the 5% rule, that was basically come from Danny Kleinfelter. He's a former professor at Texas A&M, that said if you got a 5% increase in price, a 5% decrease in cost, a 5% increase in yield, you'll produce more than 100% increase in net returns. And so I talked to my ag economist friends and said, yeah, be careful about saying that too much, because you can't predict yield. But the things that we can focus on with technology is decreasing costs and increasing yield. I think we can accomplish those tasks. And I think 5% is a low number. I think we can do better. And on the right, I wanted you to look at the adoption rate of technologies. The first is yield monitoring maps, soil maps. 10% of small farms are using technology. So there's a large gap, unfilled gap of where we can approach that. The mid-size, 55%, still a lot of numbers that can be grown there. The auto steer, same numbers, 10%, 52%. So I think we can really grow that. And then the variable rate applications, again, it's all tied to this spatial locations, and it has to be affordable. And I think with all technology, what we're evaluating is does it work, and is it affordable, and what's the ease of use? Because that all of those barriers will affect adoption. And one of the first things that we worked on was tractor guidance. Because we can reduce in inputs and minimize that over applications in places, and just the farmer fatigue. People who use it really love it. So because they're less fatigued, they can pay attention to their equipment more. They can sometimes conduct other business while they're working in the field. And we've definitely shown increased profitability. And so we started. So I bought an auto steer tractor when I got to to my research center. And one of our tractor drivers, he's 20 years experience. He got on it and he was supplying fertilizer, and he told me that he had applied 39.9 acres on a 40-acre field, but he wanted to track himself and see if he could do at least as well as the tractor, if not beat it. And so he was manually driving, but he applied 42.9 acres of fertilizer on a 40-acre field. And to me, I was thinking numbers like, the number of passes, the number of fields, the number of years, that is a lot of money. Time, product, fuel. So we got with an ag economist at the University of Arkansas, and we basically spatially mapped with someone driving versus auto steer. And so we saw 20 to 30% efficiency gains with auto steer, and we tested experience of drivers. So people with less than 5 years, people with 5 to 10, people with more than 10 years. Obviously, experience helped, but still no one got close to auto steer. And so we built this this tool called Tractor Guided Assistance, and it's a tool that's hosted by the University of Arkansas. And one of the big expenses was the actual product. So if you use a John Deere or some other, that comes with the tractor, there's an added expense to that. So I kept looking for ways that we could lower that expense. And so that's when I started working with Mike and his team, and we've evaluated the GEODNET. We haven't published on it yet. We're still doing some analysis, but I can tell you now we're not seeing any differences in any of the systems. So it's as equally as good as some of the other products that we've evaluated. Another area that we work on is digital soil mapping, as I maybe have mentioned. We basically create these soil maps, and then we put a bunch of environmental data layers together, do some modeling, make some predictions, evaluate them, and then add more data. And so it's like a living system that continues to grow. But all of this is really based on spatial location, and any applications that we do with soil mapping has to be high spatial resolution, because I'm heading towards this variable rate technologies and things that we can do that affect the fine resolution of applications so that we can improve the profitability. And so one quick study that was an interesting study, we have this agroforestry site where you can see the trees planted in rows. We had pecans, poplars, and oaks. And so we created some soil maps based off some digital elevation models and some terrain. We did some electrical conductivity scans, which also we need high resolution with that. And I'm planning on trying to use GEODNET to link to my electrical conductivity. But we drive these scans across the field. You can see the high density of points to get the electrical conductivity, create the maps, and then the maps, we ultimately want to figure out how do we use it. And so my colleague, Amanda Ashworth, decided that we would put GPS collars on cows, and every time they dip their head to eat and forage, then we get a GPS point. And you can see in the center is the point cluster of where the animals are eating, and then the maps of where we're seeing different properties are definitely, you can see the relationship in that. And so what we found out was the forage quality was different. There was differences in nutrients. And so if you're thinking about managing, you would think about where would my inputs actually pay back? The trees are actually different growth rates depending on where they are in the field. So the oaks like the dry areas, the wet spots, the oaks didn't do well, but the poplars and the pecans did great. So if you're thinking about where you would invest, how you would invest, you need to think about where you are spatially on the landscape, and then use the tools that have high spatial resolution to help you manage. We're also really investing in drones, and I think this is a technology that is continuing to grow. People are continuing to find use for it. As Mike had mentioned, the spray drones, I think, are huge. They're coming. So what we're doing is using some remote sensing to identify areas in the field that may need different applications, or identify the weeds, and then use the drones to go target that to minimize product, minimize time, minimize labor. And all of that requires these very precise geospatial locations because you want to hit your target. You got to know where your target is exactly, and you got to be able to hit that target exactly. And so that's been our focus. We've got some other work that we're doing, but that's just a summary of some of the things that relate to the RTK. And if you want to contact me, my email is there. Happy to work with anybody. We love to explore, and that's what we do. We test and evaluate and summarize useful technology that we think can be applied to mid and small size farms.
Thank you, Phillip. I was going to turn it over now to Joey to talk a little bit about some of the things that Phillip talked about, but actually in an applied way to actually putting this on the farm and actually utilizing GEODNET in real applications around auto steering. Joey.
Yeah, Phillip did a great job explaining some of the issues that my company, Deep Sand Tech, addresses. That as a hands-on, I'm seeing that low adoption rate. So when I'm looking for affordable technology like auto steering, rate controllers, so we can not only give this technology to big farmers, but small farmers, because in the past, RTK was just too expensive. Auto steering by itself is limited. It's a luxury, like he said, but if you do not have a correction signal source like GEODNET provides, it really doesn't benefit as much. There is benefit, but having the repeatability to reduce input costs, because like Phillip said, we can't control yields. In a bad year, we can control input costs. If we lower input costs, those are where you survive. In a bad year, a farmer, has to do whatever he can, but if the yields aren't there or Mother Nature, we just can't control it. So we're doing our best to keep finding affordable technology like we offer that'll work on new or old equipment. It seems like when I first got into the technology side, all technology was kind of geared to new equipment. A lot of farmers, I'll talk to farmers every day. They just don't even know that there's options for older tractors. And then that gets me into some of the product lines we offer. We have an auto steering system or guidance system for every tractor, anything with the steering wheel, and our guidance systems will even work on four-wheelers side by side. And you can get RTK accuracy even on our guidance. So, and then we even have hydraulic systems, steer-ready systems. So we're not limiting to big farmers, small farmers, new or old equipment. Our goal is to help every farmer become more efficient so they can survive, because like Phillip said, 80% of farmers are considered small, and there's not a lot of information out there to help them. And, most people are just wanting them to buy a new tractor. I wouldn't still be farming if that's what I had to do. So that's the whole goal behind my company, is to reach out to everybody. We got guys that have 10,000 acres and we got guys that have 60 acres. We let them know information like this, like, here's a return on investment. I mean, each place is a little different, but traditionally in the past, RTK systems plus subscriptions were 20 to 30,000 and plus 1,000 a year. Well, that's not the case anymore. We have auto steering. The one that has the variable rate option is 7,000, and that includes GEODNET. And you're able to get, even on a 50-year-old tractor, 1-inch accuracy, repeatable. Now guys are able to do some farming practices they weren't able to do to help survive that drought. Let's lower that input cost. Let's, be able to use variable rate. They didn't even know. Like, we'll talk to guys, it's like, I didn't even know my equipment was able to do that. So we can prove any auto steer will pay for itself. Now it's finding the most affordable one, and as Phillip touched on, easy to use. Traditionally, RTK was made to look difficult. I mean, I can simplify it to a farmer. You're going to have a set reference point that doesn't move. So now you're going to be able to come back to that same line and have 1-inch accuracy year after year. Now you can do a lot more things, and any farmer can do it. And now you also have remote support that we provide, and I think we're the best at that. you're able to get someone on the phone, no matter if it's between 9 and 5, or if you give us a text, we'll be there. Like after hours, we have a ton of easy material to help guys. So that's why partnering with GeoDNet and being involved, yeah, we're all in the same boat. We're wanting to help everyone because it's not just ag, but that's what we specialize in. So I definitely appreciate the opportunity to, express what our company does and how we kind of align with the USDA and what Phillip does and what Mike's doing with GeoDNet. It's growing fast, and we're here to help any farmer, anybody. And I guess it's time to pass it over to Chris. I'll let Mike kind of take that part over.
Yeah, thanks, Joey. Thank you. Yeah, I think seeing that the technology can be used really and pay back within one season, I think is an integral part of helping folks adopt it. I think when the equipment's $30,000, it becomes a real head scratcher for customers to understand whether this is going to pay back or not. But when you can pay it back in one season and the upfront costs are lower, it becomes a much easier value proposition. And that addresses a lot of the challenges of bringing precision ag to smaller farmers. Next, I want to have Chris talk a little bit about sort of leaning in. So Australia and New Zealand, I want to give a little background. My first experience with auto farming, I meant to mention this earlier, actually dates back to my first company, which was Crossbow Technology, a pioneer in sort of IMU plus GPS sensor fusion. We had a customer in Brisbane named Ag Systems, which later became Beeline Technologies. And they really were very, very innovative at the time. This was like in 1999, 2000, coming up with the very first auto steer systems for farm tractors and really early days of RTK. And one of the things that led me to understand is that the folks in Australia and New Zealand, they tend to be on the cutting edge of farming. And I think nothing could be more exemplified by the work that Chris is doing with Agri Automation to bring to market and to actual practical use really fully autonomous solutions. So with that, Chris, could you tell us a little bit about what Agri Automation is doing?
Yeah, thanks, Mike. Great to be a part of this, and great to be a partner with GEODNET as well. I think what we just referenced there about the markets in New Zealand and Australia being hungry for this technology, I think a lot of it's driven here. Farmers here don't have the benefit of any subsidies or anything like that. So extracting value out of their farming system has a lot of challenges. And when we look at a country like Australia with land area and very small population, so there is a real shortage of qualified, competent operators. So the days of being able to go out and hire a great tractor driver or a bunch of great tractor drivers is getting increasingly difficult. So that's where there's really a increasing demand for technology that goes to the next step. So taking over, not only taking over the steering, but taking over the full functionality of the machine and becoming driver optional. And so that's where Agri Automation is specialised in autonomous technology. We're also working a little bit with the driver assist and the steering, but trying to focus mainly on looking after customers that want to take that next step and move into a fully autonomous or driver optional solution. For now, we're mainly focused on horticultural crops and permanent verticals, and that just happens to be an area where this technology is with the more intensive farming operations. The permanent verticals are such as nut crops and vineyards, citrus, backups of that. That's seems to be the area where there's the most demand right now. So our company specialises in several different systems. We have a retrofit system similar to what Joey was describing with the steering, but going a step further, the system comes out of Poland, called GoTrack, and it retrofits into practically any horticultural tractor. Takes over, manages the steering, has a control center, picks up on the CAN line, and that enables us to run a record and replay system whereby the job is driven once by an operator, and all of the aspects of that job are recorded, and then it's stored in a named file, and that can be pulled down from the cloud and deployed time and time again. So the critical part with any form of autonomy has to be reliability and accuracy, because we're not just talking about going out and driving accurately along a line and going back and nicely driving along a side. We're talking about sending a tractor that's completely unmanned out, and it needs to be able to make its way into the field and turn with absolute precision into a row space between two sets of trees, and it needs to do this time after time after time reliably and without incident. So that's where having a precise and reliable network is absolutely critical, and that's where GEODNET has really stood out for us, and that they could offer a solution that is not only reliable and precise, but it's cost effective.
Thank you, Chris. I was going to show a couple of the videos. One from the first video from the GoTrack system, which is Chris highlighted is a retrofit kit onto an existing tractor that offers full autonomy capability. So they add not only the steering kit that Joey highlighted, but also additional sensors to bring this tractor up to a fully autonomous state and do operations. This is a demonstration of a mowing. Chris, do you want to comment at all about where you see customers using the GoTrack solution in Australia and New Zealand?
Yeah, thanks, Mike. So where this technology is working in the main is the boring and repetitive tasks, such as mowing, spraying, these type of things, which are, it's the same every time. So we're called the job once, and as you can see in the video, the headland, the tractor's automatically lifting the mower, makes the turn, lowers it, and just continues it, and it works like this for as long as the path has been recorded. And what we've seen working together with the GeoWork level of 1 centimeter accuracy every time.
Thank you, Chris. Thank you. You're breaking up a little bit. Chris is out in the field in New Zealand, and it demonstrates another common challenge, which is internet. And thank goodness for Starlink, and these solutions like this are really helping, I think, bring good connectivity, but it still can be a challenge. I'll show the next video, which is a video that is with Burrow. And Burrow is partnered both with Agri Automation as well as GEODNET, and doing some amazing innovative things around small robots that work in everything from greenhouses to vineyards to orchards. Again, very affordable technology. And Chris, you want to comment a bit about the Burrow solutions?
Yeah, thanks, Mike. So Burrow is a very important partner for us in Australasia. So we've been bringing the Burrow product out of the US and to Australasia for the past 2 years. And as you see in the video, we're coupling the burrow together with tools like mowing and herbicide spraying, as well as the traditional use of carrying produce and fruit and in likes of nurseries, pulling trailers, and so there's a whole host of different use cases with products like burrow, where it's a swarm effect. We're using a small electric robot, so very clean, very low cost, low operating cost, and again coupled with the GEODNET solution, we've got the accuracy to deploy a swarm of these machines into the field with reliability.
Thank you, Chris. So as a summary, before we go on to the Q&A, I wanted to highlight that precision ag works. It's scientifically proven to improve yields, lower input costs, and have tremendous benefit to the farmer. The challenge in the past has been affordability of equipment and the RTK signal itself. Those challenges are largely resolved. So now I think the biggest challenge is what Joey highlighted, which is education. And that's why we're doing this webinar today, and why all four of us are engaged in so many activities to help bring awareness that affordable solutions are here today, and they can benefit all farmers from big to small. We also talked about the differences between semi-autonomous solutions and fully autonomous solutions, and how both are important. Both have a role to play in places with reduced availability of labor and higher labor costs. Fully autonomous is already starting to take impact in places like Australia and New Zealand, and that's an amazing thing to see. And that solutions that are farmer friendly, well tested, and affordable are key to enabling. And GEODNET itself is open to work with any hardware, software manufacturers that can help bring those kinds of solutions to marketplace. We think that is really a way to grow. Ease of use, as Phillip said, super important. And ease of use means it needs to be out there facing the farmer and working in the field. And so with that, that's the prepared part of the presentation. And it does look like we have quite a good set of questions already piled up. So why don't we head into questions? Brian, if you want to just start with them. And I think the first couple are for me, but then some of the later ones, I think, go to some of the other speakers as well.
Excellent. Thanks, Mike. Yeah, we'll start with David's question. How will your network deal with the upcoming datum change in the US?
Yeah, so we'll definitely support it. Having a lot of stations throughout North America. I think he's referring to the update of the North American datum NAD, and we will definitely support that. We have also even been contacted by some of the folks at NGS who are interested in using our data to help validate that this datum change goes off smoothly. So definitely looking forward to that, and we'll support that.
David is also asking what receiver and antenna do you use?
Yeah, so that's a great question. The stations are uniformed. They're made by a company called HiFix Spatial Intelligence. It is a triple frequency GNSS receiver. There is also a calibrated HiFix antenna that goes with it. That calibration for that triple frequency antenna can be found in the National Geodetic Survey catalog of calibrated antennas. Brian?
Okay, next question is from Ilja. It's if auto steering tractor is working on the field, does it need someone to supervise it?
I think that question we should hand over to Chris, given he's doing the most of the fully autonomous solutions.
Yeah, thanks. So we would typically refer to it as managed autonomy. So it provides from a field office, from a phone, from a vehicle. You can log in and see screen footage, etc. So yes, in the main, we would suggest that somebody is supervising. That doesn't mean they need to be on site in the field. It just means that the machine is under supervision. And typically that might mean that one person that might have traditionally been an operator could be then stationed in a vehicle or in an office and could be monitoring, overseeing, say, 3 or 4 or 5 machines and getting the efficiency that way.
Thank you, Chris.
All right, the next question is from Gary. What is the level of GEODNET cooperation with autonomous precision AG research groups in the U.S.?
Yeah, thank you, Gary, for that question. We would like to see more. We have a good partnership with Mississippi State University. I've been looking into, doing additional research on what their, I think it's called their autonomous agriculture lab, and that's gone well. We open to more collaborations. Clearly, the USDA has installed a GEODNET node and is publishing research on that, so that's been super helpful. But we are open and welcome to more university collaboration around autonomy and development and ag, and more government collaboration as well. Absolutely.
Yeah, one thing I wanted to say, Mike, too, is just to clear the air, is that we did not receive any grants or funding from GEODNET to study this product. We purchased it and Joey installed it, and we're basically independently checking the technology.
Excellent. Next question. This is from a different Gary. According to the table earlier, subscription for GEODNET is less than $500 per year. What hardware is needed to utilize this subscription?
Thank you, Gary. Yes, the typical retail price for GEODNET from most of our partners for single-use RTK annual subscription is $40 per month, or $400 per annum. Again, that's a retail single-user license for RTK. Any equipment that supports NTRIP, the NTRIP standard, whether it be a Trimble receiver, a Leica receiver, TopCon, U-Blox GPS module, anything that can support NTRIP and RTCM 3.2 correction format will be compatible with GEODNET. So there's really a huge number. There are really literally thousands of products out there that are compatible with the GEODNET network, as those standards, both RTCM 3.2 as the input stream format, the data format, and NTRIP as the delivery mechanism, are pretty well standardized. And again, at geodnet.com/NTRIP, you can get yourself a free trial and try it out with your equipment. If you do find any equipment compatibility, maybe a very old receiver that's only supporting RTCM2 or something that else, we can always work with folks on that. But generally speaking, we found the kind of compatibility of our network with equipment in the field to be exceptional.
And Mike, one of the last questions submitted, we have David, who's asking, how many users does GEODNET have?
Yeah, we're happy to answer that. We can't fully answer it because we have two kinds of customers that use GEODNET. So the first kind of customers are people, say, referrals through users of Chris's equipment or Joey's equipment. They're directly connecting into the network. So we do have visibility to those. We call those direct users or resale users. We also have a variety of wholesale customers who buy bulk station data from GEODNET to power their own correction services. And some of those partners we can't name, but there are folks already in the agricultural market that provide L-band correction services. There are folks doing PPP-RTK that acquire data through GEODNET to power their GNSS correction networks. And those networks, we don't have visibility to how many people are using those on a daily basis. But the portion that we do have visibility is averaging around 10,000 users a day, growing at about 200 users per week at the current moment in time. We do see that accelerating as the coverage is improving and the awareness of GEODNET is improving. But yeah, on any given day, around 10,000 folks are using the network directly, and not including people using it indirectly through wholesale partners.
Excellent. And a couple more submissions. How do you ensure the location accuracy of the RTK stations?
So we use, as mentioned earlier in the presentation, we use PPP on a process that precisely calculates the coordinate of every station and then rationalizes that coordinate into various datums, various international datums. That software that is used to monitor and to establish the station coordinates is a piece of software called NRCan, Natural Resources Canada's PPP software. It is one of the more famous pieces of PPP software out there. We are working on integrating additional PPP monitoring tools into our network that will provide additional coordinate validation ongoing, but NRCan is a very tried and true way to do this. And we have a high volume agreement with them where we can upload all of this data, because as you can imagine, with over 10,000, over 12,000 online stable stations, we're having to run a tremendous amount of coordinate calculations all the time.
One other more question from Mike. He's asking, is the $40 a month based on a yearly commitment?
No, that is the monthly commitment, and the yearly commitment is $400, and that is for unlimited access to the GEODNET network, so you can use it anywhere in the world for that device. We do lower priced solutions for more on-demand usage as well as for high volume usage, and those models are being used by customers. For example, like a drone deploy, which is flying thousands of drone flights a week on GEODNET. They have a model that is, because they have so much usage, that is based on a different pricing model. So it's flexible, but the base model, if you're a single user, have a tractor in the field, want to get onto the network, is $40 a month or $400 a year.
Excellent. Up to now, those are all the questions that have been submitted. If you have another question, we have a few more minutes that we can answer those. So please continue to submit those. Otherwise, Mike, I'll have you close out this next slide, and we can go from there.
Sounds good. I'm sure everybody could use a few more minutes in their day, so we could be happy to answer questions offline as well. I think all four of us are available. All four of us are passionate to see more precision ag happen. Making this technology available and ubiquitous is something that we're all committed to. All right. Well, just wrapping up the webinar, if you'd like to reach out, those QR codes go to our YouTube channel and website directly. Also, feel free to reach out to me at mike@geodnet.com. The Agri Automation website's easy to find, as well as Deep Sand, as well as the USDA Small Farms, Dale Bumpers Small Farm Research Center. So please feel free to reach out, and appreciate folks tuning in to this webinar.
Thank you, Mike. We're going to wrap it up. Thank you for attending the Future of Farming, Affordable Precision with GEODNET's RTK network, brought to you by GPS World Magazine and our sponsor of the event, GEODNET. A recording of this webinar and other upcoming webinars from GPS World will be posted to gpsworld.com/webinars. Thanks again, everyone, for attending, and we hope you'll join us again soon for another great GPS World webinar. Thanks.